Hello learners, I, Mrs. KULKARNI SHEETAL V, Department of Instrumentation Engineering, AISSMS, Institute of Information Technology, Pune. In this session, we are going to discuss Audiometer. These are the listed contents which we are going to cover up in this session. Audiometry is a technique used to measure the ability to hear sound. Also, for the evaluation of hearing acuity, it measures the hearing threshold. The human range of hearing is 20 Hz to 20,000 Hz. Ear anatomy. The outer part, middle part and inner part, these are the three parts in ear anatomy. Outer ear consists of pinna and ear canal. Middle ear to transfer the movements of the air in the outer ear to the fluid-filled chambers of the inner ear. Inner ear consists of cochlea. Sound waves enter the outer ear and travel through a narrow passageway called the ear canal, which leads to the eardrum. The eardrum vibrates from the incoming sound waves and sends to these vibrations to three tiny bones in the middle ear. These bones are called the malleus, incus and stapes. The bones in the middle ear amplify or increase the sound vibrations and send them to the cochlea. Once the vibrations cause the fluid inside the cochlea to repel a traveling wave from along the basilar membrane. In this way, the human can hear the sound. The types of audiometric techniques are pure tone audiometer and speech audiometer. Now we will see the block diagram of audiometer. George van Beske, a Hungarian scientist, designed audiometric testing method for plotting the hearing threshold based on the patient's signal. It consists of electrical and mechanical section. The electrical section includes an oscillator and modulator circuits for the generation of desired test signal. The mechanical section consists of automatic attenuation link to the writing system, control circuits for the driven motors and master clock generator for the control of all timing functions via a logic control circuit. The instrument generates a pure tone signal which is presented to a patient through an air conduction earphone. The subject is told to press a switch when the tone is heard and to release the switch when it is not heard. The switch controls the motor-driven attenuator of the audiometer. When it is pressed, signal intensity decreases and when it is released, signal intensity increases. A pen connected to the attenuator traces a continuous record of the patient's intensity adjustment on an audiogram chart. A variety of ways, each suited to the investigation of a particular problem. These are the switches for the control. In this way, the audiometer works. Audiogram. It is a graph that shows hearing sensitivity. Along the top of the graph are frequencies noted in hertz. A frequency is also often referred to as a pitch. The sound level measured in decibels, dB, are located on the left side of the graph. Audiometer specifications. Monitor instrument make model number MI7000 having the listed specifications. These are the references referred while creating this video. Thank you and keep learning.